it looks like there's been another sea lion update. So, we're going to start our session by updating Sea Lion. And while I sit here going through the motions to get this updated, I'll sit here and chat to anybody who cares to show up. I use BTRFS and snapshotting and all kinds of things to make this updating process go well. Let's see, which version does it think that I'm running? I wish they didn't update as often because it's this process is difficult, annoying to go through. I actually basically set up the subdirectories that it's in to be read-only. And I have to go change all of that, and it's kind of annoying. Oh, also, I should do a sound check. I haven't done that yet. So, can you all hear me? Indeed you can. So, sound works. Yay! All kinds of things got updated. Let's see here. Now, we are going to quit out of this because I want to make it read-only again. And here are some sirens because I'm near a fire station. And the sirens have now gone away. You may or may not have been able to hear them regardless of whether I muted my headphones or not, but I chose to mute them anyway. Now see here. Let's run these tests because they were not working. And I was in the process of debugging, and yes. So, there we go. So this test failed, and I have an idea as to what might have gone wrong with this test, but I'm very curious as to what happened that went wrong in the parsing of this test. So we're going to set our breakpoint there, then we're going to run all tests again, and it will fail to hit the breakpoint because I don't know what's wrong with GCC and breakpoints. And so we'll set the breakpoint there. Let's see what happens. We will set the breakpoint there. Let's see what happens. Oh, I know what the problem is. That's silly of me. I was not running it in the debugger. So of course it didn't hit the breakpoint. And I actually set it up in the thing for the first error message. Because if I look here, there was an error message. It's been a while since I've looked at this, as some of you may know. Though I don't appear to have a regular audience as of yet. Yes, expected factor parse aborted was the error message, and this is the only place where that error message appears in the entire thing. So this should be the first instance of expected factor parse aborted. No. There. Yep. So, let's go back to the debugger. Now, we got here and we did not find a factor. Why did we not find a factor? So when we called parse term, well, okay, parse factor. What were the parameters to parse factor? Parse factor got the start. So what is at the start? The start is the token close brace. So it tried to parse a factor. It couldn't because it found a close brace. Parse term. It tries to grab a factor. When it sees a factor, doesn't see a factor, goes, I expected a factor, and it complains. It probably shouldn't be complaining here, but this is just fine so far. And what in fact does it see? Okay, it's also at the close brace. Parse rel clause. So parse rel clause. What is rel clause? So this is probably expecting a less than or greater than. This is for all the things that are parts of less thans or greater thans or whatever. And here it's trying to parse this, and it's expecting a term. Why it's in the middle of parsing? Oh, so it's trying to do that because it's okay. Then bool term term, rel clause. Okay. So we try first for factor, then term, part of the plus or minus, then part of a relational thing, then part of a Boolean expression. Then we try to do parse expression. And here is where this works. So when we're doing parse expression, okay, and so we fail to get an expression here, which should be fine actually. Again, this should be failing to get an expression because it's at the closed curly brace. Parse expression statement. So parse expression statement looks for a semicolon at the end of the expression, and if it doesn't see a semicolon, it complains. Yeah, if it doesn't see a semicolon, it goes, something's wrong. But again, it's parsing the expression. Whatever the value of start here is here, it is not, but here in parse statement. Okay. So statement. So we're looking, what is start here? Start is the closed paren. Of course, that's not a statement. And it probably hasn't moved. But this one does have, if we see a open curly brace, then we treat it as should be treating it as a statement list or a statement sequence. So this is where we should be right here. Is we should be looking for, we should have seen the open brace, and then, right. So what's going on up here? Parse sequence. Oh, but this is parsing the last statement. So a parse sequence tries to do parse statement. If not statement, then break. So basically, when this fails, we go, okay, we couldn't find a statement anymore, and we return the statements that we found so far. Our statements node should have one binary operator. Statements. And we should, in the statements, we have one a numeric literal, and that numeric literal is 5. So indeed, and if we look at the original test, this is this 5 right here. So we've seen one statement in our sequence. And we break. Okay, so this is all good right here, right? So I should actually be able to step out. Step out. Step out. Step over. So rel clause, yep, basically not a rel clause. Step out. And again, not a bool term. Step out. It failed this if check, so it's already down to here. Step out. And statement wasn't anything. And so, hey. Okay, we're parsing an expression statement. We didn't get an expression statement, and so a statement should have basically been nothing. But statement is something. What kind of a something is a statement? Oh, it's nothing. Okay, it's a nothing. Good. And then we try to move the statement. Oh, and we shouldn't move the statement because we might not even have a statement. But this move, let me ask Claude just to find out. And statement is not even a null pointer. Statement is in fact an AST pointer, and so moving an AST pointer that happens to be pointing at null certainly is not a problem. And what is after? After, I don't know what it is, but it was optimized out, and so we don't know what it is. Okay, so this is fine. Statement here is null. After is whatever it is. It's optimized out, which is very annoying. So if not statement, and here statement is a null pointer, so if not statement, it should have broken, which hopefully it did appear to skip all the way to the bottom here. So statements node is all of the statements, which contains a statement list, contains 0. So this is a pointer to an AST node. The AST node that it's pointing at is a statement list, and that statement list contains exactly one statement. Which, yes. And then step over that. So we're getting an actual sequence out of our parse sequence. Okay. But then it says, didn't find blah after statement sequence. Okay. Debug. So, what does remainder equal now? No contained value. remainder is an iterator, like that shouldn't be possible for it not to contain a value. What's going on here? So it's pointing at the open. Am I not advancing? I am not advancing the I'm not advancing the finish, so that finish is not, remainder is not pointing at the right place once this thing is complete. That's what's going on. So parse sequence is not doing the right thing with regards to that. All right. We are going to look over the code for parse sequence to find out what it's doing wrong here. Parse sequence. I'm glad I double checked this. There we go, parse sequence. So, start, finish. While we're not at the end, look at try to parse it. If we didn't get a statement, then we're done. Otherwise, we set the start to be the remainder. Oh, this is silly. We shouldn't be doing that. That's not what we should be doing at all. Yeah. This should be start. Okay. Now let's try running our test. We'll still get a bunch of error output that we shouldn't be getting, but it now works. Okay, so we fixed the bug. There's other bugs in which factor is claiming that the parse failed because we didn't find a factor when we're supposed to find a factor. And yeah. These are not valid error messages, even though they did help us find the problem. So first, we're going to, oh yes, of course there's no repository there. Okay. So we have two things that we've fixed here. Okay. So we're going to commit just these two files because these two files together contain a test and the fix for that test. And then we're going to tell what the bug was. Just a bit. Oh well. People being loud. People somehow like to be really loud with their motorcycles and stuff around here. It's very annoying. Oh. Actually, that should be test/parser test. There we go. All right. Now, let's try building Lexer test again. Build it. Run. It's no longer the Lexer test, probably should be renamed. And I'm going to give it the input that I did before. And the result, 6. And this is basically correct. And got an if, got an open paren, got a identifier A, got an operator less than, got a identifier B, got a close paren, got an open brace 5. Yeah, this is all parsing. This is right. Again, we got all these messages here that we probably shouldn't have. They aren't exactly bugs, but they probably shouldn't be there anyway. I'm not really sure what to do here. I do very badly with error handling on this. So result 6, done. And that's the right thing, because A is not less than B. They're both 0. Now if we did this, and then we just copy in like all this, like that, and we get 5. So there we go. All right. So this part all works correctly. Now, I do have destructive assignment. So this is not a functional programming language. And I don't have any kind of variable declaration. Variables are declared when they're assigned. All variables are the same type. And we have if-else style, but no looping. I could add 2 things. I could add functions, which would introduce identifiers of a different type. So then an identifier might be a function name, or it might be an integer. And if it was a function name, you couldn't could you assign? That's a good question. Should you be able to assign to it if it's a function name? If so, then maybe we should have a syntax for just anonymously declaring functions. But then if you do that, you would need a special keyword for the function to be able to refer to itself, to call itself with. And that can never appear on... Yeah. Interesting. So if I introduce function calls, that would in fact be a way to introduce looping, because You could just have looping be recursion. The other thing I could do is introduce a specific looping construct. Now, if this is a functional language, I wouldn't have a choice because there would be no explicit looping construct that I could introduce, because explicit looping constructs have a tendency to imply that a particular variable gets updated over and over again to be increasing values. And so if I'm not doing that, then that's not can't do looping in its normal form. And in functional programming languages, you can't update a variable's value once it's set. It stays set forever. I mean, that's not absolutely true. Almost every functional programming language has an escape hatch where you can set the state if you want to. You're just strongly discouraged from using it in most circumstances. So for all practical purposes, it's true. You can't do looping if you have a functional programming language. But this is not a functional programming language, and so it's perfectly reasonable to do looping. But in functional programming languages, since you can't do looping in the standard way, the way you do looping is you do looping by recursion instead. You have recursion and not looping. And so I could, if I introduced functions, then I could have recursion, and then I would basically have something like looping. But the other thing that functions add is they add variable scope, which is not a concept the language currently has. It's a fairly complicated concept to introduce. I think that I should just go for an explicit looping construct. And I'll go for the simplest and stupidest one that I can come up with, which is the while loop. So, yeah, that is what we will introduce. But first, I'm going to go through parser, and I'm going to remove a bunch of the extraneous print statements that print out things that are not useful. So, stupid JetBrains not understanding focus follows mouse. Expected factor. There we go. Expected factor. We're just going through here and looking for things that got printed out that probably shouldn't have gotten printed out. There. So all of those probably shouldn't have gotten printed out. This one is probably good. And it's basically remove the things that got printed when they shouldn't have been printed. And that's very trial and error, but that's what we're going to do. And so now we're going to compile this again. And then we're going to run another this, and we're just going to cut and paste the input and put it in here. And now we don't get out any scary error messages. And we still get our correct program out. I should probably also fix this to work right, but I don't really feel like doing that right now. I want to add looping. What did I change here? That's what we did. So we look at the diff here. It's all about adding, like, we had these, so we add a whole big bunch of other ones, right? And then we had this, and we removed the equal token. Like, we did a bunch of things, and so that's let's see if this is 68 characters or less. It would help if I spelled echo correct. All right. There, we'll push to GitHub. So, let's first add to the while loop here. So we have if statement, then we'll have as another production that we're going to add here. We'll add yes. There. If statement, while statement, assignment. All right. So that's actually pretty simple, adding that. If we want to add tokens to the HTTP, should add keywords here. We need so we added while as a token. That's the only new token we need. Want to make sure that we added while expression. Yes. Just like we have if expression, we have while expression statement. Yep. Okay. And now down here, where we're parsing out keywords, yep, and we need to add while to our list of keywords. There we go. And we should add it as a thing that we can tokenize. So let's add given us. We'll just add this at the end because we don't need much of a test for while, because it's not like anything that's significantly new was added here, right? Oh, cancel. No, that's not what I wanted. Emacs. Except that's not what we want. So this is a fairly complicated expression, so let's break this up. And let's make this a little more indented here. I wish it wouldn't do that. Okay. So this is a long, long list of tokens. Yes, that's exactly what we want. Wanting to test various ways in which the thing could be and this is the wrong number of tokens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Where it got 24 from, I do not know. And going to be careful about our requires and checks. Yes. And here we're going to do check. Here, this is, yes, we want an unsigned integer here. Yep. No. This is wrong. So first, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So we've got closed paren, 10. Yep. No. Curly bracket. And yes, it needs to be an open curly bracket. That is true. That is true. And no, the token, oh yeah, that's true. Yep. Operator equal. Identifier. Up. Operator plus. Yep. $11 should be 1. Yep. 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 So semicolon is 12. Yep. 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 Is this right? Looking for the if keyword. Yep. I am starting to get tired, and in the time that I've been streaming, I haven't attracted any interest whatsoever. Well, okay. I have attracted for a total of 2 minutes interest from somebody named Tackling. And how long have I been doing this now for? For an hour. I've been doing this for an hour. Tackling's shown up for 2 minutes. I'm starting to get a little tired. This part is a bit tedious. I might finish it off stream. I'm going to end it for today. Alright. I hope you all have, well, all you who aren't here, have a marvelous rest of your day.